In this video, what I'll do is punch out all of the VCAA questions we haven't kind of had time to finish in class. So this first one was the addition of ordinates question, and what we've got is this drug X comes in 500 milligram tablets. And the mathematical model that says how much drug is in the bloodstream is this particular function here, B of t. So what we're going to do first of all is find the time in hours it takes for drug X to reach a maximum amount in the bloodstream after one tablet is consumed. And answer, so the time in hours. So let's just have a look at the graph. So they give us the actual graph. So we're looking for the maximum value, which is somewhere around about here. Okay, so what we're going to do is we're going to define this function here. And then for 2 marks, our method is going to be to say b dash t equals 0. Okay, so we're going to set the derivative of this function here to 0. And that is going to give us the point in which it's at its maximum. So we're going to say t equals. All right, so I'll swing in the calculator and run the definition. So menu 1 for define. F of, I'll do b of t equals 4,500 over 7 times open brackets. Now remember to go to e, as in e to the x, not e from here. And we've got negative t on 5, take away e to the negative 9t over 10. Right, I think that looks good. Okay, well, we'll find out in a second. So what I'll do is go and say shift negative d dt of b of t. So that's given us the derivative function. And because I know there's only one stationary point, I'm just going to use a solve, not 0. So solve and control and negative. So ants equals 0 for t. And it gives us this value here. So I'm going to write that down, 10 on 7 log e 9 on 2. Okay, now we'll just check whether that is in fact correct in a sec, but it looks good because it's in the form like that. So the way I'm going to check it is just ask it to do the solve again, but I'm going to force an approximation by putting a decimal point next to one of the values in here. And it says the maximum occurs at 2.14, and graphically we could see that it was around about 2, so this is a perfectly reasonable answer. Alright, so the next one it asks for is the average rate of change for 2 marks. Okay, so to get the average rate, all we'll do is we'll say the average rate is equal to b of 6 take away b of 2 over 6 take away 2. So there's our method. And we're allowed to do that to 1 decimal place. So we need an approximation for that. So I'm just going to go and control divide b of 6 take away b of 2 over 6 take away 2, which is 4. And again, to force the approximation, I'm going to hit or put in a decimal point in the question. And we've got negative 33.5 milligrams per hour, I think it was. Okay, part C, I can't remember what that was. It might have been integral or something like that. Okay, 6 hours after one 500 milligram tablet of the drug is consumed, a second identical tablet is also consumed, or is consumed. The amount of the drug is shown independently, is shown below. Okay. So on the graph above, sketch the total amount of drug X in the bloodstream in the first 12 hours after tablet 1 is consumed. Okay, so basically what's going to happen is we've got the first 6 hours just as it was before. So it's got to go directly on the line. Mine's a little bit sketchy. That's the first 6 hours. Now what happens at the 6 hour mark is someone takes a second tablet. So what we're going to do to sketch what the graph should look like is we'll use addition of ordinates. So this is going to be 6, whatever this value is, plus 0. Okay, so whatever this value is here, 180 or 90, whatever it is, plus 0, so we're still at this point. All right, so now we need to just get some other points for some shape. So this one here is when they're both the same, which is about 1 box and about a bit over 3/4 of the box. So this will be another 1 box and about 3/4 of a box. So it's going to go up to around about here. So it's not exact science, but we're going to get pretty close. Okay, this one is going to be this little section added on plus a full one. So it's going to end up somewhere around about here. All right, this one is going to be a 1 and a bit added onto here. So 1 and a bit. All right, and we'll finish it off by doing this little bit added onto here, which looks like around about that. Okay, so now we'll just do the classic join the dots. And we've got our 2 graphs, or our graph, using addition of ordinates. Okay, so find the maximum amount of drug X in the bloodstream in the first 12 hours and the time in which the maximum occurs. Give your answers to 2 decimal places. Okay, so we can see that the maximum amount of the drug is going to be here, and it's around about 440 milligrams of the drug. Okay, so we know that it's going to be about that and about 8-hour mark. Okay, so what we're going to do is we need to put the 2 functions together. So I'm going to make a new function called C of t, which is the original function, plus this second function that basically just moves 6 units to the right of the original. Okay, so we've got b t takes 6. All right, so what that's going to do is it's the original function and it adds the same function just shifted over 6 units. And this basically here simulates first tab. This is the second tablet being taken. Okay, so again, what we're going to do then is to find the stationary point. We're going to get the stationary point of this by doing c dash t equals 0. So we're going to get its derivative. So we're going to slam this out on the calculator pretty quickly because what we'll do is we'll go b of t plus b of t takes 6. That's going to create the new kind of added ordinates function. All right, then what we'll do is we'll go a shift minus for a derivative, d dt of that long nasty thing sitting in the answer slot. So derivative of the thing sitting in the answer slot. And it says it's this thing. Okay, so we don't really want to write that, and that's why we write just c dash t equals 0. So now I'm going to do a solve. So solve, and it's that derivative. So we're going to go and control ants. So derivative equals 0, please. Solving for t. And because we want a decimal approximation, because it says give answers to 2 decimal places, we just put a decimal in the question and it forces the approximation. So we're going to say t equals 7.78, which was around about what we predicted. I said 8 by the graph. So it's 7.78 hours. Now what we'll do is we'll put this value of t back into c of t. So we'll do c of 7.77 dot dot dot, the full value of it in there, and that's going to give us the amount of drug, which we said I think was about 440 milligrams. So the original function is this one here. This is b of t plus b of t takes 6. So we're going to go that control equals and pipe. Okay, I don't know whether did it put it in? No. Control equals pipe t equals this value here. In fact, I didn't even have to put t equals. I can just go up and hit enter. And what that will do is substitute for t everywhere where it sees a t. So it's going to put in 7.779, etc., etc. Because this is a decimal, it'll automatically approximate it. So I said 440, it says 455, which is good. 455.82 milligrams of the drug. All right, so there's this one done by addition of ordinates. Okay, so Yeah, good question there. It's probably the last time I've seen sort of addition of ordinates in that form, like a graph sketch, but you never know where it's going to come up. Okay, the next thing we'll do is the composite functions questions. So here we are with the first one. So this is all tech free, so I'll leave the calculator out of this. So for 1 mark, what we were doing in the previous class when we were doing composite functions is doing a whole heap of tests. Range of G needs to be a subset of the domain of F. But for 1 mark, all they want us to do here is write down F of G of X. So it basically says just do the composition, please. No questions asked. So we're going to do F of, here's G of X, 2x plus 1 equals 2x plus 1 all squared plus 1. So all I've done is grab that and stuck it on for X. So that's F of G of X. And that's it, really. I think this question probably would have gone on to get you to do something else. But yeah, at the moment, that's all we need to do. Okay, this one here is again 1 mark. So all we need to do is do it. We don't need to do a range of the inside as a subset of the domain of the outside. None of that stuff. So we're going to say that G of X equals F of 1 on X squared, okay? So what it's doing is F of X is basically just putting itself into itself, really. So it's 1 over X squared all squared. Okay, so I've replaced X, this thing here, with this thing here. Okay, we can't leave it like that even for 1 mark. This is not good enough for the answer mark. So we're going to go 1 over, well, let's actually rewrite it as 1 divided by 1 squared is 1, x squared to the 2 is x to the 4. State change, flip that thing. Means that our g of x function is x to the 4. Okay, evaluate g negative 1 of 16, where g negative 1 is the inverse of g, which is what we just found. So we are doing a 1 mark question. So again, all we need to do is state the answer of g negative 1 of 16. So no working out is actually required, although I do need to get an inverse. So I'm going to do the working out fairly quickly. I'm just going to write g of x as y equals x to the 4. No need to write out swap x and y for 1 mark. This is answer only. So I'm just going to go x equals y to the 4. Now I'm going to 4th root both sides, or raise it to the quarter. Gives me y equals x to the quarter, which is the 4th root of x. Right, so now g negative 1 of 16 is the 4th root of 16, and the 4th root of 16, the number when multiplied by itself 4 times, is 2. All right, so there's our answer there. Okay, and it continues. Okay, if the function f has the rule this, and g has this rule here, find integers c and d such that f of g of x is expressed like this. Okay, so let's just do f of g of x. G of x is the linear. And what we're essentially doing is putting the linear on for x. X plus 5 all squared. Take away 9, I think it is. Take away? Yep. Okay, so it's not in the required form. So yeah, student today in class basically did this by difference of 2 squares. But yeah, I'll do it and I'll stick with the way I did it, which is x squared plus 10x plus 25, take away 9. Okay, and that is x squared plus 10x plus 16. Jump on the cross, 8 and 2 plus and plus. X plus 8, x plus 2, and it's in the required form. So we're just going to formalize that by saying c equals 8, d equals 2. The other answer you could give, if you wrote the brackets around the other way, would be C equals 2 and D equals 8. That would be perfectly appropriate, but only one of them is required, so choose one of them. You could choose both. I think that wouldn't be an issue. All right, state the maximal domain for which f of g of x is defined. Okay, so looking at the inside function here, which is this, it seems to have a domain of all real numbers, but that actually is not going to be the domain of the resulting composition. And the reason for that is the resulting composition, if we draw just the parabola component, is going to have x-intercepts at -8 and -2. And it's going to look something like that. Now that we know in methods that you can only square root values that are 0 or positive. Okay, so what that means is that this function won't be defined between these two values here. Okay, for the rest of it, it's defined. So the maximal domain is going to be for x is an element of, we're going to go -∞ to -8, union with -2 to +∞. Yeah, that's one way of describing it. Mistake there. So they've got to be squared off, like so, because they will produce, if you use -8, it'll produce a 0, which is actually fine, because you can square root 0. What's another way of writing that? X is an element of all reals, not including the values of -8 to -2. That would be another way of describing it. You know, whatever you want. As long as it's described mathematically correctly, then you'll get the mark for that. This was an interesting discussion point in class. So for 2 marks, what we've got is 1 answer mark for correctly stating the maximal domain. The method mark will come from the graph. That's perfectly acceptable for a method. So examiners will be able to see that your method involved sketching a graph of the function described in the previous part to the question. So yeah, that would be perfectly acceptable for the mark. Okay, and on to this one here, and this one is brutal. Okay, now I'm going to go through this fairly quickly because I've done this question a million times. Every time at the end of the year, like September, November, October, students ask about this one. So I've done it so many times, but I remember doing it for the first time and having to really think hard about it. So it's from 2017. It's question 7. I'll pause the video at the end of this and look up the stats on it. The state went really poorly in this question. Anyway, enough on that. Let's get into it. So we've got this square root function and its domain is 0 to +∞. So this is just a standard square root function moved 1 to the left, but we're going to start it at 0. So I'm going to put 0 into the function. So do f of 0, which is 1, and it'll look like that. So it would in theory continue down to there. But because it's chopped, all right, that would be the resulting graph. Now, because it starts at 1 and goes to +∞, the range is going to be 1 to +∞. All right, so not too bad to begin with. All right, let G, okay, equal this quadratic. C is less than 0. Okay, find the largest possible value of C such that the range of G is a subset of the domain of F. Okay, so what they're doing is they're getting us to restrict the domain of this, essentially so we can form a composition later on. Okay, so let's just check what the dom of F is. So I'm going to go up and check the domain of F. So it's 0 to +∞. Right, so I need the y values of this graph here to fit within this domain here. And I think the best way to do it is to actually do it graphically. Okay, so what I'm going to do is sketch g of x, which is x plus 3, x plus 1. All right, so -1, -3, and our parabola is going to look like that. Now, what I can see here is that its domain is negative infinity, so we're swinging in from this side, and imagine looking up there, we've got y values, and here is where it comes down to 0. Okay, now beyond this point here, what's going to happen is the values go negative. Okay, it can produce negative y values, and that's a problem. Okay, that's a problem because the domain of f is 0 to positive infinity. Okay, so what I'm going to say is that the domain of g, so domain of g, will need to be negative infinity up to negative 3. Okay, we're not going to let people use values lower than negative 3, because what that does is that the chances are then that they'll produce a negative value. Okay, what the chances are, they will produce a negative value. Okay, so this restriction on g will cause the range of g. Okay, because imagine it, all I'm doing is including this part here. Okay, and not including this part here. You can see the y values are 0 to positive infinity. All right, so it's this domain restriction that'll cause the range of it to be 0 to positive infinity. Okay, so state the largest possible value of c. So we're going to formally state that as c equals negative 3. All right. Okay, here's where it gets a little bit hairy. Okay, for the value of c found in part B1, state the range of f of g of x. Okay, so let's just do f of g of x. So that means put that g of x in for x there. So that's going to be x squared plus 4x plus 3. So that's going to be square root of x squared plus 4x plus 3 plus the 1 in the original function, I think it was. Yes, 1. Okay. X, 2, and we've got a perfect square. Okay, so now what we've got to do is work out the range of this function here, where its domain is going to be negative infinity to negative 3. So the value of c found in part B1. Okay, so this is, so what we've got to do is we've got to be able to recognize sort of what this function looks like. So this is a parabola that gets square rooted. All right, so what we want to imagine is a parabola that gets square rooted. So let's do this parabola here, right? So it goes negative 2. And what it would be is it's going to be a parabola. It's going to look like that, 2 units to the left, okay? And essentially, if you want to imagine it, okay, it gets square rooted, all right? Now, what that will do is produce a function that looks like this. All right, so it's going to actually be a linear function. And the way to kind of work that out is that if you imagine these two here, all right, if I square root the square, it just produces the graph of x plus 2. All right. Now the danger though is x plus 2 is a graph that looks like this, 2, and it goes through like that. Okay. Now this x plus 2 is not the same as this graph here, because what happens is that it's a parabola that gets square rooted. It's not actually this particular linear function here. Okay. All right, so this is basically the graph of x plus 2 all squared, square rooted, over all real numbers, but we know it gets chopped at negative 3. All right, so what we're going to do is chop it there, okay, meaning that we only want this part here. We're going to use this part here to calculate its range. So we can see the highest number, range, is going to be positive infinity, so it keeps going upwards. So we're just going to work out what negative 3 produces in this one here. So negative 3 plus 2 is negative 1. Negative 1 gets squared, which is 1. 1 squared is 1. So it is from 1, okay, the y value there is 1, to positive infinity. Alright, so if you understood that, you're doing well, because I won't lie to you, that took me a little while to cover that off when I first did that question way back 6 years ago. Okay, state the range of f of h of x. Okay, so here's a new function that they've introduced. So f of x squared plus 3 equals, so it's still just that x plus 1. So remember, f of x is equal to root x plus 1. So that's going to be x squared plus 3 plus 1, which is x squared plus 4. Okay, so because it's the inside function and all reals, okay, what we can do is just imagine what this is going to look like. So its range, all right, or the range of this is 3 to positive infinity, and the domain of f, where's the domain of f, is 0 to positive infinity. So this is just basically this composition is just going to work without restriction. So all I need to do is sketch this, okay, and that will give me an idea of what the graph looks like, and then pick off the range. All right, so again, the way to imagine what this looks like is to do it in parts. What we're going to do is imagine what this parabola looks like, and then we're just going to square root the parabola, okay? So the parabola is x squared plus 4, so it's the standard parabola, move 4 units up. Now all you do is you imagine all these values being square rooted, okay? Now the key value that I'm after is this one here. So the y value there is 4. Now all I'm going to do is square root that 4, which is 2. And what you'll find if you graph this on the calculator is it produces kind of this function here. It's actually the absolute value function, but you don't need to know that in methods. All you need to know is that basically the lowest point is 2, okay? And that means I can officially state the range as 2 to positive infinity. So there's that question there. I'm going to pause this and just scour the internet for the examiner's report, and I'll write the stats up for these questions. Okay, so appearing on the screen now is the examiner's report. So where is 7A? So starts fairly well, 65%. Okay, we're able to pick the range. So yeah, 65%, not bad. All right, and then we dip down. So B part 1, 29%. B part 2, what I thought this was hard, this part, 20%. And part C, a little bit better, 30%. Okay, maybe that's because it was kind of like they did a bit better because the composition didn't need any restrictions, so you could kind of more easily see the range. But again, that's probably, indicates fairly difficult question, that one there. All right. Okay, so that was all of the VCAA composition questions, and I'll wrap this up by doing the inverse questions. All right. So basically, when you do an inverse question on a VCAA paper, or on any paper really, just have a look at the number of marks, 3. So that implies showing or using full function notation and stating domains, and probably mentioning swap x and y. For 1 mark, I wouldn't bother with all of that stuff. But yeah, definitely for 3 marks, we do the whole thing. So we're going to say let y equal 3 on x, take away 4. Right, that's that there. Swap x and y. X equals 3 over y, take away 4. X plus 4 equals 3 over y. Let's head up here. Y equals 3 over x plus 4. F negative 1 of x equals 3 over x plus 4. Now what's its domain? Well, let's go back to the start. We probably should have done this. I've been a bit keen here. And we'll state its domain of the original is, as stated, all real numbers, not including 0. That's because it's a hyperbola moved 4 units down. So it looks like this. Alright, so we can see from there its range of f is going to be all real numbers, not including -4, because there's an asymptote there. So because that's the range of the original, that will be the domain of the inverse, where x is an element of all reals, not including -4. And that makes perfect sense, because if I put -4 into my inverse, I'm going to get a divide by 0 error. So what happens, according to the rules, does actually make legitimate sense. Okay. So 2 marks. So rule for the inverse, h -1. So we've got to use the notation, and I would state the domain even though it's only 2 marks. So we're going to go y equals 2x to the 3 plus 1. Swap x and y. All right, now our domain is going to be, so that is the standard cubic moved up 1 unit, and so it's going to look like that. So its domain is all reals, and its range is all reals. Okay, we can see that it will produce all y values. So x equals 2y to the 3 plus 1. 2y to the 3 equals x take 1. Y to the 3 equals x take 1 on 2. Head up here. Y equals x take 1 on 2 to the 1/3, or the third root of both sides, whichever one you want to do and whichever way you want to state it. h -1 of x equals, let's use third root notation, doesn't really matter, where x is an element, so its range becomes its domain, or reals. Okay. Alright, these ones here, part of the graph of the function is shown below, same scale has been used. So basically all I do is I draw the line y equals x on my paper, and then just reflect what I've got here. So that will go like that, that will go like that, and then I just look for the matching answer, which is C. Alright. Which one of the following is the inverse of this? Okay, so that's just the square root function, and it's been moved 3 units to the right. It's multi-choice, so you can use CAS for this. So feel free, if you don't know how I've worked out that moves 3 to the right, feel free to graph it. Once we get to transformations, hopefully you'll know why that one goes 3 to the right. So it's the standard square root function. So standard square root function looks like that, and it's just moved 3 to the right. Okay, so we can see here its range is going to be 0 to positive infinity. That means its domain, when it gets inverted, is 0 to positive infinity. So that's gone. That's gone. Oh no, that's all right, that one. And that's gone. Okay, now you need to know that the inverse of the square root function is a parabola. The inverse of a parabola is the square root function. So what we can do is get rid of C, because this person here, or whoever's worked that out, is thinking that the inverse of a square root is a square root, and it's not. It can't be. It's got to be one of these parabolas here. So which one are you? Okay, so again, what I do is I do a quick swap x and y. 2y takes 6. X squared equals 2y takes 6. This can just be quick and dirty. X squared plus 6 on 2. And I can see straight away that it's this one here. So I don't need to finish off the working out, because all I care about is, have I circled the right response? All right. Okay, this one here, it's important to know what this graph looks like. It's 1 on this function here, which is kind of like a hyperbola, but will only include values on one side of the hyperbola. I'll explain in a sec. So if this was just the standard hyperbola, we would know that it moves 2 to the left, okay, and it would look like that and like that, okay. Now what happens is that we can't square root these negative values, so it actually won't include this side here, will only include this side, okay. Again, if in doubt, because it's an MCQ, check the graph, but it's faster if you just know what these graphs look like. Okay, so I can see here that the range of this function is going to be 0 to positive infinity. Now why did I do that? Because I want to rule out some of these answers. Gone, gone, gone. So it can either be this one or this one. And both of them look plausible. So I'm just going to do this algebraically. So quick and dirty, 1 over root y plus 2. No swap x and y, all that stuff. So I'm going to do y plus 2 equals 1 on x. Y plus 2 equals 1 on x squared. And I can see it's going to be take 2. So it's got to be A. All right. Almost there. Okay, hopefully. So this is just another of those graph questions. So draw your line in. Okay, that is going to go something like that when I reflect it, and that's going to go something like that. So I'm just looking for that. E. Okay, oh yep, okay. This one here, we will use some CAS for this. Okay, so what we need to be aware of is that when we invert it, it has to be 1, 2, 1. All right, so what I'm going to do is do a quick and dirty sketch of this. So the way I'm going to do it is define f of x equals 2x cubed, take away 9x squared, take away 168x. Now, all I want is the x values where the stationary point occurs. Okay, that's all I want is the x values where I'm going to get stationary points. So to do that, I'm going to go shift minus ddx f of x. Now I'm going to run a solve, ants equals 0, or I could do zeros. Ants for x. And it's basically telling us that it turns on the line x equals -4 and 7. Now, because this is a positive cubic, what it's going to look like is something like this. All right. So it can't have a domain, which is a set of all real numbers, because we can see here that it fails. Remember that horizontal line test I was talking about? Okay, so it fails the horizontal line test. Okay, so if I draw a horizontal line there for all real numbers, we can see it hits a y value there, there, and there. So that won't produce an inverse function. Okay. So what about this one here, 7 to positive infinity? So if we restrict it at the stationary point and onwards, we can actually see that that's a one-to-one function. So we've got a winner in B. And what we'll find is, like, if we look at -4 to 8, okay, if I restrict it there, what that means is, let's draw, so we can see here, 4 to 8, what we can see is it'll produce 2 of the same y value there. Okay, so it's not one-to-one because it kind of hits the stationary point and comes back up again. So yeah, all of them, try the rest of them at home, and you'll find that all the rest of them don't produce a one-to-one function. Okay, the inverse of the function this. So again, that's a sort of a type of hyperbola. I don't know, it's probably not called a hyperbola. I don't really care what it's called. I just need to be able to graph it. So it goes up 4 units, okay, and it would typically look like this and this, but we don't take the negative side because that will produce errors for maths methods, or it's not real. Okay, so it's only going to be this side here. So we can quickly see that the range of this function here is 4 to positive infinity, not including 4. So its domain is going to be 4 to positive infinity. only one with 4 to positive infinity is this one here. So I back myself here. Can't be, can't be, can't be, can't be. So I'm not even going to do the algebra on this. I'm so confident that, yeah, we're going to get this right. Okay, these are the last 2 questions. So if you've made it through 40 minutes of this, you're doing well. This one here, f of x equals x. Okay, now this is important to know that anytime you do a composition and get x in return, what has happened is you've composed a function of its inverse. Okay, so what's going to happen here is if I take one of these functions and inverse it, it's going to be exactly the same. Right, so let's just try this one here. So I'm going to go x equals 2y, y equals x on 2. And you notice that that's not exactly the same. So A is out. Okay. And I know, because I've done this earlier, I know that the answer is going to be E, and I'm just going to show you y equals 2 take x is the way I'm going to write that. Now I'm going to invert it. X equals 2 take y. X take 2 equals negative y. Y equals, divide it by, and it's 2 take x. So notice it's exactly the same. Okay, so when you compose a function of its inverse, it'll always return x. That's the only time that's going to happen. So it must be the E response. Now the other way you could do it, if you kind of didn't know that, is define f of x equals 2 take x. And I think if I just go f of x, yeah, it does that. So you could just do that by process of elimination. Okay. All right, this one here is more kind of a chapter 7 question, but yeah, it's good that you guys put it in here. So there's a real system of doing these ones here. One of these comes up every couple of years. So to do it, all I do is I define the first function. This is trial and error. So the way that we want to do this one is trial and error. So we define the function, or the first response, which is f of x equals x squared. And then what I do is I use this thing called a functional identity. Okay, so I literally just type that into the calculator. So I'm going to go f of x, take away f of y, equals y take x multiplied by f of x times y. And if this is the possible rule for the function, what it will do is go, yeah, true, all right? So if you don't get true, what that means is that's not the rule. So all we do then when this question comes up is I just go up, 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 and just choose the next one. So x to the 2 plus x to the 4. And just copy the functional identity in. No, afraid not. All right, so I'm going to cut to the chase on this one because I know that the answer is D. All right, so I'm just going to go and define it as a hyperbola. Now, I only know that because I did this question earlier. So I know that it's D, but I would have tried log that first C. But yeah. All right, so I'll show you what happens here. We define the function and then use the functional identity. And what it will do is it's going to say true. So that's why this is the one that satisfies this rule here. Okay, so we don't want to do this by hand. We don't want to work all of this stuff out by hand. We want to just get the calculator to do an equivalence test to see when it's going to be true for which particular function. Okay, so really, really common question. That one comes up all the time. All right, so there it is, 43 minutes of VCAA question fun. So hopefully you enjoyed that. I don't know how many minutes of this video you managed to watch, but hopefully you got something out of it. Cheers.